Section 5: Fundamentals of Software Quality Assurance (QA) Testing. Let's do a quick recap of the software development lifecycle process. As you may already know from other sections we've covered, the software development lifecycle is a step-by-step process followed to design, develop, and maintain software applications or systems. The phases of the software development lifecycle include requirements gathering, design planning, development, testing, reporting, and deployment maintenance. What is quality assurance? Quality assurance is a process of verifying whether a product or service meets certain quality standards and ensuring customer satisfaction by preventing defects and deficiencies in the system. Quality assurance, or QA, is about making sure that the end product or outcome meets the stakeholders' expectations, also known as acceptance criteria or requirements, which are collected from the client as sometimes even the customer. What is software testing? As you may already know from other sections that we've covered, software testing is the process of evaluating a software system or its components to identify any potential bugs, defects, or issues that may affect its functionality and core performance. The goal of software testing is to ensure the software is of high quality, works as expected, and is suitable for its intended use as designed. Software testing and quality assurance is interchangeable and oftentimes used in the place of one another. What is a software bug? A software bug is an error, flaw, failure, or fault in a computer program or system that causes it to produce an incorrect or unexpected result, or behave in unintended ways. Bugs can cause crashes, data loss, security vulnerabilities, and other undesirable outcomes found during the development process or in the risk of after the software has been released, which can be devastating. Why do we need to identify bugs? In the 1980s, there was a system known as the Therac 25 in the medical field. The Therac 25 was a medical imaging system designed for radiation therapy. The Therac 25 delivered high doses of X-ray radiation to patients. A software bug in the system caused the machine to malfunction and deliver overdoses of radiation to patients, leading to severe injury and many cases of death. This is why identifying bugs in the process of software quality assurance testing is critical in situations like this and can be even life-threatening if overlooked. The process of software quality assurance testing has evolved and come a long way. Software QA testing is a crucial part of the software development process and is essential for ensuring the quality, reliability, and security of software systems. The field continues to evolve with advances in machine learning, artificial intelligence or AI, and cloud computing expected to have a major impact on software testing practices in the years to come. In the field of software QA testing, there are several different types of job roles and positions available in the market today. Some of these positions or opportunities that exist in the market today are manual software QA tester, quality assurance tester, Selenium software automation QA tester, agile software QA tester, and software developer in test or SDET. These are just some of the titles of the job opportunities and positions related to software QA testing in the market today. In the current market and trend for wages and employment in software testing, the median wage is around $40 to $50 an hour USD. Also, the median wage varies as well between 75 to almost 150K annually per year. Now, this does depend on the state you live in or country, as well as your experience. There are a lot of factors that are important when looking for a job opportunity in this field, and at the moment, it's growing much faster than average. Between the year 2021 and 2031, there are expected to be more than 19,000 software QA testing positions available in the market. As we dive in to the software testing lifecycle, let's explore the types of software testing. There are two main types of software testing: functional and non-functional. Functional software testing focuses on verifying that the software functions as expected by testing its features and functionality. Non-functional software testing focuses on the software's non-functional aspects, such as performance, security, usability, and compatibility with other systems. As we dive in to the software testing lifecycle, let's explore the types of software testing. There are two main types of software testing: functional and non-functional. Functional software testing focuses on verifying that the software functions as expected by testing its features and functionality. Non-functional software testing focuses on the software's non-functional aspects, such as performance, security, usability, and compatibility with other systems. The first type of software testing that we will explore is functional software testing. Functional software testing ensures that the software application or system is high quality and bug-free, with core features and functionality working as designed. The most common types of functional software testing are unit testing, integration testing, smoke testing, regression testing, and user acceptance testing. We will go into more detail with every single one of these testing types under the functional testing umbrella. Let's go over an example of a functional testing scenario. Here we have a user login. A popular e-commerce website is developing a new feature to help its users log in to their account more easily. This feature is called Single Sign-On, or SSO, authentication. Functional QA testing of this new Single Sign-On SSO feature would involve testing the functionality of the following: username, password, and forgot username or password. Testing this new SSO feature means trying valid and invalid username and password combinations, testing the password reset functionality, and testing the Remember Me feature. Functional QA testing ensures that the system displays error messages for incorrect login credentials and can successfully log in and be redirected to the account dashboard with the correct credentials for that user. The second type of software testing is non-functional software testing. Non-functional software QA testing focuses on aspects of the software application or system such as performance, reliability, security, scalability, and usability under different circumstances. The most common types of non-functional software QA testing are performance testing, reliability testing, scalability testing, security testing, and compatibility testing performed today. We're going to go into much more detail and use scenarios to demonstrate these non-functional testing types. Let's look at a non-functional testing scenario using the scenario from before, the user login. The e-commerce website wants to evaluate the performance of the system when many users simultaneously attempt to log in to the system and to ensure that it remains and performs stably and is responsive under this potentially heavy traffic. Non-functional testing scenario of the e-commerce system performance upon multiple users would involve the user login parameters, such as the website should remain stable and responsive with a response time of less than 2 seconds for login page load, even under heavy traffic, and remain functional. So here, these are the requirements for the performance test for this application. The website should remain stable and responsive. The response time should be less than 2 seconds. And the website should remain functional. These are the requirements for the e-commerce system when more than one user or multiple users are logging in at the same time. Under the umbrella of functional software QA testing, there is an area known as manual software testing. Manual software QA testing is a type of functional software testing that manually tests the software to identify any defects or issues. The process involves manual execution of test cases, manual comparison of the actual results with expected results, and manual reporting of any defects found. Manual testing is used to identify any major issues, bugs, or defects early in the development process so that the team can ensure high quality and reliability of the software system. Manual software QA testers use their knowledge and expertise of the system to manually test the core functionalities, non-functional requirements, and even user interface of the software to identify issues. Manual testing is important because when a system or robot looks at something and may overlook an issue, a human with considerable experience of a particular system may notice unusual behavior that a system may not. Let's discuss the advantages and disadvantages of manual software QA testing. Some of the advantages of manual testing include more flexible and adaptive test cases and scenarios, human insight and analysis to detect any issues that a computer cannot, low cost to implement and incorporate in the test cycle or project, and also manual testing can help detect issues or defects in early stages of the process. Some of the disadvantages of manual testing is that it can be time consuming and labor intensive for some of the projects. This process can also be inefficient and unreliable sometimes. There is limited test coverage and also it can be a very slow process. The test cycle may not be consistent with the data. And as we've mentioned, labor intensive, manual software testing, you are basically spending more time and effort on doing something over and over again, systematically.
Automated software QA testing. Software automation QA testing is a type of functional software testing where manual tasks or actions that have the same predicted output every time is automated using a script written in a programming language such as Java or Python. The goal of automated software QA testing is to increase efficiency and accuracy by automating repetitive and time-consuming tasks, as well as providing consistent and reliable test results given certain conditions. There are significant benefits of using automated software QA testing in a software testing lifecycle because it increases efficiency, improves quality and accuracy, more reliable, cost effective, and also very scalable depending on the project complexity. Automated software QA testing can be performed at various stages of the software development lifecycle, such as unit testing, integration testing, and system testing. There are some There are many advantages as well as disadvantages related to automated software QA testing. Some of the advantages of automated software QA testing include increased efficiency, saving lots of time and effort, improved accuracy and quality of testing. It can increase reliability of the test results and reduce risk, as well as increase the test coverage and scalability for complex projects. Some of the disadvantages of automated software QA testing are that it's initially difficult to invest in due to skills needed. It can also be very complex, requiring specialized tools and personnel. It can be very difficult to maintain as changes take place in the cycle all the time. And limited flexibility and integration with several other systems.
Let's discuss some of the advantages and disadvantages of automated software QA testing. Some of the advantages of automated software testing include increased efficiency, saving lots of time and effort, improved accuracy and quality of testing, increasing reliability of the test results and reducing risk, as well as increased test coverage and scalability for complex projects. Some of the disadvantages for automated QA testing include that it initially is difficult to invest in due to skills needed. It can also be very complex, requiring specialized tools and specialized people. It can be sometimes difficult to maintain because there can be changes that take place in the cycle throughout the process. And there's limited flexibility and integration with some of the other systems. There are several popular open source or free software QA testing platforms that are used widely in the industry today. Three of my favorite platforms that I use as an automation test engineer in the industry are Selenium WebDriver for web browser automation testing, JUnit for unit testing and automated unit testing, as well as or the Cucumber BDD behavioral driven development framework as a testing framework. All three of these are open source, meaning they are free to use to the public, and highly customizable per project and